Swayam Prabha. Digital India. Educated India.
Let's get our class started today. Today we are going to look at a new topic on the dynamics of a negative feedback system, and through that I will introduce you to hands-on modeling using Vensim software. Before we get to Vensim, let us take a look at what is this negative feedback system. We have seen the negative feedback is characterized by goal-directed or goal-oriented behavior. Common similar terminologies include self-regulating or adaptive terminologies we end up using. Most of the control systems models where there is feedback involved falls under this category, where you are looking at current state versus an actual desired state, and then start taking the gap between them and try to control the system. So, most of the systems that you are going to study there is also can be classified as a negative feedback system. Examples: room temperature control, blood sugar regulation, and things like that. The CLD representation of that would be this is a kind of example based, where we are looking at current state of the system. So, this is actual room temperature represents the current state. We know desired room temperature, we fix it in the AC all the time, get the difference, and accordingly heating or cooling, whatever it is, has to happen. We know that the state of system can be represented as a stock. Desired behavior is defined as the goal of system, and discrepancies is used to affect the rate, which then in turn affects the stock of the system or the state. This is a general causal diagram of a simple negative feedback system. This goal directed action is fundamental to any human social systems also. Always there is some sort of a goal towards which we are working on in this current state, and we look at the gaps. If the gap is too high, then we start talking about inequalities and things like that, or access to basic services and needs, and try to come up with some policies or actions which will fulfill that gap. Let us look at a general stock flow diagram of this negative feedback system, or a balancing or goal seeking system, or a balancing loop system. So, you can simply represent state of the system as a rectangle, and this net inflow rate which flows into the stock and changes the stock. We have desired state of the system, let us denote as S star. We take the discrepancy and we adjust that discrepancy some fraction f every time unit until the desired state is achieved. So, this is a very general structure of the system. So, let us goal seeking or negative feedback systems. As we just saw, we have a stock S which is affected by some net inflow rate. I have desired stock S star. I have a gap. Okay. We are taking the gap as S star minus S. You can simply denote a fraction per time, denote by symbol F, as shown here. So, we already know that net inflow rate or net flow rate ds by dt, this is your net inflow rate as given in this diagram. is nothing but f into s star minus s. This f represents the fraction of discrepancy kind of added per time. There is a gap and some fraction is what we are fulfilling every time unit, or it is also called as a fractional adjustment rate. In most of the time it is not possible to completely eliminate the gap at one time step itself. It takes some time for the room to cool down. Every time some small amount of the difference is kind of added. If you think of the stock as a current room temperature and the desired cooling that we want, so some small amount of gap is kind of satisfied every time unit. So that is what we are modeling here, and the rate at which it is going to happen is defined by that fraction. So fraction of discrepancy added per time, or the fractional adjustment rate is what is defined as f. We can also denote say AT, which is nothing but the adjustment time. This can be defined as just 1 over f. So if we are instead of fractions, if its time is more convenient to us, we can define adjustment time, which is just 1 over f, and we can rewrite the original equations as inflow as ds by dt, c s star minus s divided by at. At is the kind of a symbol for adjustment time. So in coming up with a model for this negative feedback system, all we need to define is the stock, desired stock, and immediately we know the gap, and the equation for the gap is nothing but desired minus the stock. And for inflow rate, all we are going to do is either multiply by fraction rate per time, which is f, or we are going to divide by adjustment time, whichever, they are equivalent, and we define our net inflow rate. This is what we are going to learn to model today. Before we start modeling, let us start with kind of a 3 very basic pointers. When you build stock flow diagram based simulation model or stock flow simulation model, SD model as we call it, always remember the model should run without error. All units in model should be okay, and model should start in dynamic equilibrium. What I mean by dynamic equilibrium is for the given values in the system, at the start itself we do not need to observe any dynamics in the system. It should remain kind of a constant. We will look at it through an example. And when suppose these features where you can check whether there is any where units are all okay, and debug the models. If it throws an error, just check where the error is and then fix it. We will learn all these points through a simple example.